Calculations using logarithm. We have been dealing with logarithm since, and the main essence of doing it is because there are times you might be in a place and you do not have your calculator around with you, and you have to calculate some very big numbers, some very big value, some certain things that look so as though you won't be able to do it. If you have your four-figure table with you, that makes it so simple and easy for you to do. And in YX syllabus, this is one of the topics that is almost so sure that you have it yearly, almost so sure. So there is need for us to see how we're going to be using this, our logarithm knowledge to do calculation. In YX, you will see they will say with table, evaluate, or they will say without using calculator, evaluate. So when they ask you not to use calculator, you are always free to make use of your logarithm table in solving such situation. Now let's look at the principle, because this principle we'll be dealing with actually depends on the laws of indices. You know, there is a beautiful relationship between indices and logarithm, and this knowledge is what we'll be making use of in dealing with our workings, our calculations in logarithm. Let me quickly put up what will be. The first thing is you add logarithm when multiplying. When you are to multiply two values, irrespective of how big they might be or how small they might be, what you need to do is find their logarithm and add their logarithm. That is so simple to do. The second one is, whenever you are to divide, you find the logarithm of those numbers you are to divide, and you subtract their logarithm, and that makes the working so simple for you. The other one is, whenever it is raised to a power, what you need to do is multiply the logarithm of that value by the power is raised to. And the last one, the fourth one, you divide by the root when finding the root. That's what you do. Let's look at it. Let me quickly put their indication in front of them one by one. If we have 10 raised to the power of A times 10 raised to the power of B, I'm talking about the indices now. What we need to do is we equals to 10 raised to the power of A plus B. Now, mind you, from our knowledge, let me quickly put up this so that we can see it. A equals to B raised to the power of n implies that when we have log of A, in base B, it equals to n. So what we're dealing with now is common logarithm. That tells us that we have log in base of 10 of A to equals to n. If we should rewrite this in index form, that would be that we have A to equals to 10 raised to the power of n. So anytime we are to find, and you know log A equals to what? N. Log A equals to n. So when we find the log we find actually is our n. Is that clear? That's it. That is, that number equals to 10 raised to the power of the log that we have been able to find. So we have A, 10 raised to the power of A. A here is a logarithm of a particular number. So 10 raised to the power of A times 10 raised to the power of B equals to 10 raised to the power of A plus B. In this situation, we have 10 raised to the power of A divided by 10 raised to the power of B. That will equals to 10 raised to the power of A minus B. So here we have 10 raised to the power of A raised to the power of B, and that will equals to 10 raised to the power of A times B. And for the last one, where we have, let's say we have nth root of 10 raised to the power of A. According to our law that we studied earlier in indices, this will be 10 raised to the power of A, all raised to the power of 1 all over n. And this will equals to 10 raised to the power of A all over n. We are dividing. So you can see, divide the root. We divide the root by the root, nth root. Here we are multiplying. Here we subtract, and here we are adding. And this will guide our steps in calculation anytime we're to use logarithm. Let's look at the first example. The first example says we should evaluate 38.43 times 4.572. We have the numbers. What we're given, what we're calculating, actually we are calculating with the numbers. But without calculator, it will be very difficult for you to work with these numbers. That's the reason why we are employing logarithm. And this is what we're going to do. We have a particular thing here. We divide our work like this, where we have the numbers. The first number we have there is 38.43. And the second number we have there is 4.572. Now I want to find the log of this number. Log of 38.43. The first thing we're going to write out is the characteristic. And what will be the characteristic of 38.43? The characteristic of 38.43 equals to 1. Then we'll put our decimal point. Then we'll go to our table, we'll look up for the column where we have 38 and the row where we have 4, where they are meeting. Whatsoever value we have there, we add it to whatsoever value we have under the difference of 3. And from our table, what we have there is 5, 8, 4, 6. 5, 8, 4, 6. So the log of this number is this. We'll come back to this also. The characteristics for this value is 0. 0 point. We stop there. Then we'll go into our table. We'll look up for 45, row 45. Sorry, column 45, row 7. Whatsoever we have there as our value, we add whatsoever we have in 2. Row 2 under the difference to it, and that value here is 6601. Since we are multiplying these two numbers, what are we going to do to their log? We're going to add their log together. So we add these two together. 6 and 1 will give us 7. We have 4 here. We have 4 here. We have 2 here, point, we have 2 here. So, under the log, we have this. But that is not the final thing we're going to be doing. What we have been given is in number, not in log. So, we need to find our answer also in numbers. Now, from log, if we have the log and want to get it back in the number, what do we need to do? Simple. We just need to find the antilog of this value here. Now, mind you, the antilog of the value we're going to be finding that we'll be looking up from the book, from the standard table, is 24 under 4 plus the difference of 7. We're going to look at the column where we have 0.24 under row 4. Whatever we have there, we add the difference that we have under 7 also to it. And that will give us 1757. Remember, we are here to use this too. In order for us to get the final value of this calculation, we're going to write this number in standard format. That would be 1.757 times 10 raised to the power of 2 times 10 raised to the power of 2. So if we have this, the final answer we have there will be 175.7. 175.7. That will be the answer. 175.7 to this. Example number 2. We have evaluate 97.86 divided by 6,543. That might be difficult for us to do without calculator. We do not have calculator, but we have forfeiture table. That makes it so easy for us also at the same time. Like we have earlier, we have the numbers, and we're going to have the log. In the number position, we're going to have 97.86, and we're going to have 6,543. We do the ruling. We'll find the log of this number, and we'll find the log of this number. Log of 97.86. The first part, the characteristic, we're going to find from this value, and that will be 1 point. Now we're going to look from the column 97 under the row 8 plus the difference we have under 6. Whatsoever we have there 9906. And we'll come to this part also. The characteristic of this number is 3. 3 points. Then we'll go to the other part where we'll find it from the table. That we're going to look for column 64 under row 4 plus the difference that we have under 3, and that equals to 8158. Now here, since it is division that we're dealing with, what are we going to do to the log? We'll be subtracting. So we have minus. You subtract this from this. This will be 16 from 8 from 16, that will be 8. We have 9, this will be 4. This 8, this will be 7. We have 1 point. Now here we're going to have 1 minus 3. That will be minus 2. But you remember, we used to write it as what? Bar 2. So we have bar 2.1746. About 2.1746. To now know what the value will be, we have the log already. We have the answer in log form already, but we need the answer in number. So what do? We'll find the antilog of this number, and we're going to start with this fractional part. We're going to look up for, in the antilog table, 0.17, the row where we have 0.17, under the column where we have 0.17 under the row 4 plus the difference we have under 8, and that will equals to 1496. 1496. Now we're done with this. Then we need to use this bar 2. Remember, bar 2 is what? Minus 2. Okay. Now we have to write this in standard form. That will be 1.496 times 10 raised to the power of. Now we use it as what? Minus 2. And to write this number out, what would that be? That would be 0.01496. That would be the value of this expression. 0.01496. Example number 3, we have this. We have to evaluate 75.35 raised to the power of 3. That might be a very cumbersome if we need to be multiplying it one after the other. But easily we can come and say the number there is 75.35. Then we can come to log. What will be the log of 75.35? The characteristic of this number will be what? 1. Beautiful. 1 point. Then we're going to look for the column where we have 75 under the row 3. Whatever value we have there, we add it to the difference we have under 5. And that value is 8771. We have the log already here. But that is not where we're going. We want to find the power. Power of 75.35 raised to the power of 3. Since we have the log here, what we just need to do is take the log, multiply that by the power 3. So this will be 3 times what we have here. That will give us 3, 21, 1, 21, 3, 24, 6, 3 plus 2, 5. So we have 3.6313. That's what we have when we multiply that. We have the answer now in log. We need to find what the answer will be in the number in which we have been given the problem. So we need to find the antilog. Under the antilog, we're going to find whatsoever we have under the column 0.63 in the row 1 plus whatsoever we have in the difference of 3. that equals to 4279. Row 0.63, sorry, column 0.63, row 1 plus whatsoever we have under difference of 3. That gives us this. But then that is not the final answer. To find the final answer, we'll write it in standard form. That is 4.279 times 10 raised to the power 5. This 5. So how do we write this? How do we write out this number? This number will be what? 42790. That's the final answer there. Example number 4. Want to evaluate fourth root of 530. That will be very cumbersome for us to do without calculator. And we're not using calculator, but we're going to use our table. Now let's look at what we're going to have there. Under the number, we have the number we're dealing with here is 530. The characteristics under the log of 530 will be what? 2 points. 2. Then we'll move straight ahead to go and look out for what is the value we're going to have under the column of 53 and the row 0. And there we're going to have 7243. That's the value we have. Now to find, that is for 530. But we want to now find the fourth root of 530. That will be that this 7243 divided by 4. Divided by 4. Let's divide this by 4 and see what we're going to have. 4 in 2, we have 0. In 27, we have 6, remaining 3. In 32, we have 8. In 4, we have 1. In 3, we have 0. So, the value under the answer under the log is what we have here. 0.6810. But then let's find the antilog so that we can find the number we can work with. We're going to be looking for 0.68 under 1 plus difference of 0. There is no difference of 0. So we'll just be looking for 68 under 1. And 68 under 1 will be giving us 4797. To find the final answer here, you just try to write this in standard form. That will be 4.797 times 10 raised to the power of 0. And this will be 4.797. So the fourth root of 530 equals to 4.797. Let's look at example number 5. Here we have the numerator where we are going to be multiplying two numbers together, and we have the denominator where we're going to be multiplying another two numbers together. Now, just in the same way, we're going to have our numbers and we're going to have our log. Under 8, the first one we have here is 83.17. So let's find the value for that. Let's find the log of 83.17. The characteristic is 1, and the multiplier for that is 9200. The next number we have there is 649.2. The characteristics for this is 2, and the multiplier for it is 8123. I would love for us to deal with the numerator first. So I say numerator. Let's look at the log value of the numerator. The log value of the numerator will be the addition of this because we are multiplying them. So let's look at that. That will be, we are adding this together, 3, 2, 3, 7, 4. That is the numerator. Then do this and extend this a little more. Okay, I have the numerator 4.7323. That's my numerator. I move forward to what I have here. There I have 653.2. And here, the multiplier also here is what? 2 points. Then I move to the multiplier. The multiplier is 8150. So the last number I have there, that's 28.3. 28.3. The characteristic here is 1. And the multiplier there is 4518. Now, what I have in the numerator, the operation there is multiplication. So therefore, what am I going to be doing to the log? I will be adding it plus. So I have 8,662.4. This is my numerator, denominator. So I have my denominator to be this 4.2668. Now, I have the numerator, I have the denominator. What am I going to do to the two? The operation between the two is division. And when it's division, I'll be doing what? I'll be subtracting. So, I'll be subtracting this from this. And that will give me 0.4655. 0.4655. That is the final answer under log. But you know I'm not going to leave my answer there as just in the log form. I need to find the antilog of what I have there. Let's look at what the antilog will be. All what I need to look at is 46 under 5, difference of 5. 46 under 5, difference of 5. And the result will be 2920. 2920. To have the final answer, I will just need to write this in standard form, and that will be 2.920 times 10 raised to 0. And that is the same thing as 2.920. So the final answer for this one is 2.920. Example number 6, we are going to evaluate this. Please, let me beg you for Christ's sake, if you say this, don't be scared. If you can do what you have been doing so far to this point, definitely you'll be able to do this. One major thing that I know about students is that when they see figures like this and they see power, they see square root and all those things, they are scared. But please, just follow the step and see what we're going to do. And you can do any other one on your own. Now, let's look at this. We have the numerator. In the numerator, we have the first one raised to the power of 3. So what we'll be doing is we're going to take this on its own first. We'll find the log and we'll multiply it by 3 to find the implication of raised to the power of 3. Then we add it to the log of this to fulfill this multiplication, and that will solve everything we have as our numerator. We'll come to this one also. We'll multiply the log of this by 2 to fulfill this raised to the power of 2. And we divide this, the log of this, by 2 to fulfill this square root. Then whatever result we have in the first and the second, we add them together to fulfill this multiplication. And that will settle our denominator. So since we have our numerator and our denominator, and what is between them is division line, what we're going to do will just be for us to divide them. And we have, that is as simple as that. Okay, solving this, we'll pick the first one. 21.63 to the power of 3. We'll find the log of 21.63. The characteristic there is 1, and the multiplier there is 3351. And to fulfill this part of power of 3, we just multiply this by 3, and that equals 4.0053. The other one we have there is 5 609.7. The characteristic here is 2. And the matrix we have for this is 7073. To fulfill the numerator now, what is combining them, what is joining them together is multiplication. So in that situation, we'll be adding their log. So we are adding this and this. This will give us 6217.6. That is the numerator. Then we'll move to the denominator. The first value we have in the denominator is this. We have 311.2 to the power of 2. The characteristic of this value is 2. We have 2 points. Then the matrix we have for that is 4931. 4931. To fulfill the power here, we just multiply this by 2, and that equals to 4.9862. We'll come to this last one, where we have the square root of 59.2. We have 59.2. The characteristic of 59.2 is 1. Then we look for the matrix, that's 59 under 2. 59 under 2 will give us 7723. And to fulfill the square root that we have there, we divide it by 2. We divide it by 2, and that will give us 0.8861. So we have the value, the log value for this, we have the log value for this. And what is combining the two of them together is multiplication. So if it's multiplication, we'll be doing what? We'll be adding the two values together. We'll be adding the two values together. That will give us the denominator. So the denominator in this regard, we add these two together, and that will equal 5.8723. That is the denominator. So we have the numerator, we have the denominator. The function, we're dividing them. So if we are dividing, what we're going to do to their log will just be for us to subtract. We are subtracting 67126 and 5.8723. We're subtracting this from this. The result there is 0.8403. That is the value. The total value we have. That is our total value. But then that value is still in the log form. We need to now find the value that we're going to be having. And we'll be looking for the column where we have 84 under 0 plus difference of 3. And the value is going to give us is this 6.6923. That's what we're going to find there. 84.84 under 0 difference of 3 will give us this value. To find out what our final answer will be, we'll write this in standard form. 6.923 times 10, and our 10 will raise to the power of this 0. Raise to the power of 0, which is the same thing as 6.923. 6.923. That is, the whole of this expression equals to 6.923. The final example we have here, example number 7, we have to evaluate this. What we're going to be doing here, you will discover that the whole expression we have is inside the cube root. So what we'll be doing is we're going to be finding the whole expression. We'll be dealing with the whole expression first, and after that, then we'll now find the cube root. by dividing the log by 3. Okay, let's start and see how we're going to do that. Still number log. We're starting with what we have inside the cube root first. So we start with 813. The characteristic for this value is 2 points. And the manticore for it is 9101. We move to the next one. That's 72.3. The characteristic for this value is 1 point. And the manticore is 8591. So we can deal with the numerator straight away. The numerator, since it is multiplication, we just add their log together. And the answer we have there is 4.7692. That's the numerator. 4.7692. We'll go to the denominator, and that's just one thing, 54.93. The characteristic there is 1, and the manticore for that value is 7398. So we'll come around to subtract that from what we have here earlier. You subtract this from this, since it is division. And the value there is 3.0294. 3.0294. So we are done with everything we have in the cube root. Now to operate, to put into consideration this cube root, we divide this. I'll do it like this. I'm going to do like this. Everything I have here, 813 times 72.3 all over 54.93. So it's just to divide this by 3. Dividing that by 3 will give us 1.0096. 1.0096. I love this beautiful example. Now, for us to have our final answer, we'll look in the anti-log table. We'll look on the column where we have 0.00 under row 9, and we have whatsoever we have under the difference of 6 to it. Hear me again. We'll look on the column where we have 0.00 under row 9, and we have whatsoever we have there, we add whatsoever we have under row 6 in the difference to it. And the value we'll be coming up with from that will be 1022. 1022. Note that this is not our final answer. How do we get our final answer? We'll write this in index sum, and that would be 1.022 times 10 raised to the power of 1. Raised to the power of 1. And that would be 10.22. 10.22. To say that the final result for this evaluation is 10.22.